Okay, so the first section says we're going to solve using the inverse method. All right, now we need to talk about this for a second because you've never done this before. You have solved this system using substitution and elimination, but you've never solved it using the inverse method. All right, so I want you to just listen for a second. Don't write this down. Just listen for a second. Here is the idea of the inverse method. When you have an equation like 1/3 x equals 7, to solve that equation, one option that you have is to multiply both sides by the inverse of 1/3. The reciprocal of 1/3. That cancels out and leaves you with your answer to the question. Now that is easy. You've done that for years and years and years. That is the concept we're going to use here. Because this equation, or system of equations, can be written as a matrix equation. All right? So here's what the matrix equation would look like. Remember this original problem that I had here? I had a coefficient times a variable equal to a number. Well, my coefficient matrix is 1, 2, 3, -1. So go ahead and write this down. This is your coefficient matrix. That makes sense to everybody? And then my variables are x and y. And they got to be in that order because x came first. So it's x and y. And then my constants are 8 and 3. This is my matrix equation that represents this system. So it's a coefficient times a variable equal to a number, just like this was. A coefficient times a variable equals to the number. So to solve it, we multiplied by the inverse of the coefficient. So what I want you, multiply both sides by the inverse of the coefficient. So what I want you to do, I'm going to erase my problem now. What I want you to do is find the inverse of the coefficient matrix. So what is the inverse? I'll call it C. What is the inverse of the coefficient matrix going to be? Well, I'm not sure. I'll have to figure that out. That's good review for us. How do we find the inverse of the coefficient matrix? What do we do first?
Find the determinant.
Exactly. So the determinant is going to be -1 minus 6. So the determinant is -7. And then we build that new matrix we talked about a little while ago, the adjoint. We'll take these two and flip-flop them. So don't think we're changing any signs. We're not. We're physically flip-flopping those two. And then we're going to change the signs on those. And then we're going to divide the whole shebang by -7. So your inverse is 1/7, or 1/7, 3/7, 2/7, and -1/7. Everybody still with me? Now remember, in our simple basic little equation, we multiplied both sides of the equation by the inverse. So I'm going to go back to my matrix equation, and I'm going to multiply both sides of the equation by the inverse. Now, when I do that, I have to be careful because normally, the way I have it written, I would put my inverse here and put my inverse here. But this isn't going to work multiplying wise because this is a 2 by 1 and my inverse is a 2 by 2. So when I multiply both sides, I have to put the inverse before the 8 and the 3 so that I can actually do the multiplication. So I'm going to put my inverse here, and it's all squished up, but I don't even care. Because last time we were together, we talked about what happens when you multiply inverses. We talked about this. They cancel out. They make the identity. So that part's gone, and all I'm going to have left is xy. And my answer is going to come from here. So now I have to multiply this 2 by 2 by this 2 by 1, which is going to leave me with a 2 by 1. All right, so here we go. I'm going to take my first row times my first column. So I'm going to take 1/7 and 2/7 times 8 and 3. Now don't freak out about the fractions, kids. You have a common denominator. That's 8/7 and 6/7. So what's this top number going to be? 2. 14/7. 8 and 6. Now I'm going to take the second row times the only column I have. So I'll have, wish I had my bigger board. So we have 3/7 and -1/7 times 8 and 3. So that's 24/7 minus 3/7, which is 21/7, which is 3. So the answer to the problem is 2, 3. Now, most of us would never just randomly choose to solve an equation this way, but it's going to be really handy on our calculator. So that's why we're going to do a couple little ones by hand. So let's try one more by hand. We'll try B. Then we'll go to our calculator and we'll see how easy this is on the calculator. But we'll do one more by hand. It's good practice. So here's my matrix equation. I'm not even going to write the original system. I'm going to go straight to my matrix equation. And this time I'm going to leave a blank because I know that the idea is that I am going to multiply by my inverse. So my coefficients are 4, 3, -2, -1. My constants are 1, 6, and my variables are x and y. So there is the original system. So make sure you've got that down, that you know what's going on there. Now we're going to find the inverse. And whatever it is, it's going to make all this cancel out. And so the answer is going to come directly from that multiplication. The answer is simply going to be the inverse times the constants. So we need to find the inverse. So here we go. Our determinant is -4 minus -6. I got 2. Double check my arithmetic. -4, -6, subtract. 2 look okay? Yep, thank you. Hang on. We don't have that much longer. Try to stay focused. Pay attention. Now we need the adjoint, the new matrix. So we'll take these two and switch them. Take these two and change their signs. So I flip-flop these two, took the opposite of that and the opposite of that. Now I'm going to divide them all by 2. And that's what my inverse is going to be. That's what I'm going to multiply by. So it's negative 1/2, negative 3/2, 1 and 2. That's my inverse. Now remember, when you multiply, it's first row times first column. So negative 1/2 times 1 and negative 3/2 times 6. So that's negative 1/2 and negative 18/2. What is that? Negative 19/2? And then I take the second row times the first column. So that's going to be 1 times 1 and 2 times 6. That's going to be 13. And there's the answer to the question. So your answer is x is negative 19/2 and y is 13. Now, it's a hassle. It's not my first choice. I'd eliminate in a heartbeat before I do that. But once you've practiced a couple, it really is pretty efficient. The idea is you simply take the inverse times your constants. And multiplying the inverse of the coefficients times your constants, that's how you're going to get your answer every time. Something I kind of glossed over, I think, is your inverse is going to be 2 by 2. Your constants are 2 by 1. So that's why your answer always comes out as a 2 by 1. That's x and y. All right? Now, we're going to try the next one. And the next one's on the calculator. So we're going to remember what Mrs. Ford just said. Your answer, in this case, your answer is XYZ, is going to be found by taking the inverse of the coefficients times the constants. Okay? That's how you're going to get your answer. That's how we did the last two. So, we're going to put 2 matrices into our calculator. We're going to put in a matrix, we'll just call it A, and it is going to be the coefficients. So write down on your paper, A equals 1, 1, negative 3, 2, 1, negative 1, I'm doing problem A, 3, 1, 5. Those are your coefficients. 1, 1, negative 3, 2, 1, negative 1, 3, 1, 5. And then another matrix, B, which is going to be your constants. And your constants are 7, 6, I think that's a negative 4. All right? Now we're going to go to our calculator. Oh, wait, before we do that. So my answer is going to be, in terms of the matrices, A inverse times B. So that's what I'm going to type eventually into my calculator. But before I do, I need to get the matrices into my calculator. So here we go. We're going to go back. We're going to go through this again. This time I have to put 2 of them in. All right? So let's remember we do second matrix, and we click over to edit. Anytime you're putting in the matrix, you're in edit mode. Press enter. What are the dimensions of this matrix we're putting in? First, we're putting in A first. What are the dimensions of A?
3 by 3.
So we just type 3, enter, 3, enter. Do not worry, you have numbers in there. It's not a big deal. Type over them. So put in these numbers into your matrix. So 1, enter, negative 3, enter. 2, 1, negative 1, 3, 1, 5, enter. Make sure you hit enter after every number, particularly that last one. Okay, now you got it in. So now we will second quit. Matrix A is now stored in the calculator. Now we have to put in B. So second matrix, click down to B now. Now you're putting in B. A's already there. Enter. Oh, no, I'm sorry. Second matrix, click down to B and over to edit. Oh, and then down to B. I'm sorry. Got to go over to edit and then down to B. Sorry. Let me back up. Second matrix, click over to edit and down to B. And then enter. What are the dimensions of matrix B?
3 by 1.
Perfect. 3 by 1. So as soon as you put in 3, enter, 1, enter, it'll set up your matrix. And just type in 7, 6, -4. And now matrix B is in the calculator. So second quit. Now what you need to do is multiply those two together. So second matrix, and see how you got names highlighted in the menu and then you have A highlighted? That's what you want. You want A. So press enter. And now matrix A is on the screen. Then press your inverse button like we did before because you want the inverse of that. Then hit times because we're going to multiply it. And then back into second matrix. Go down to B. Hit enter. And now it says this on the calculator. Press enter and it gives you your answer. So the answer to the problem is 3.5, -3.25, and -2.25. So what that, oh, yep, go ahead. Yep.
I have a question on how you know that you're supposed to do like A inverse times B. Like, how do you know that that's the problem that you're going to use?
Okay. When you use the inverse method, the whole thing is based on the answer is going to be the inverse of the coefficients times the constants. So you just remember that. That's how it's done. So the coefficient matrix, I erased the problem, but this is the coefficients right here, right? These were the coefficients. So I need to take the inverse of that matrix. Well, I called it A. So that would be A inverse. I need the inverse of the coefficients times the constants. It's always going to be that way.
Oh, okay. Thank you.
It's always the inverse of the coefficients times the constants.
So A represents the coefficients.
The way I set it up, yeah. Yeah, that's the way I set it up.
Okay, thank you.
From the original problem. Now, I want you to understand what we just did has a geometric meaning. Those three equations in 2A that we started with, I don't have them written down on the board, but they're on your paper. Those are actually equations of planes, like the wall and the ceiling and the floor. Those are planes. And what you just figured out is those three planes intersect in the point 3.5, -3.25, and -2.25. We're now three-dimensional. We have three variables. So we're not talking about lines anymore. We're talking about planes when we have equations with x, y's, and z's in them. These three planes are intersecting in a point like the corner of the room. All right? We're going to do one more, and then we'll be done with this section. So let's do 2B. Here we go. 2B. Remember, like I just told May, the whole principle of the inverse method is you're going to take the inverse of your coefficients times your constants. All right? So you are going to put in a coefficient matrix. I always call it A. You can call it whatever you want. I use A because it's the first thing on the calculator and I don't have to go, moving up and down. Oh, be careful. What do you notice about the second equation in number B?
It's missing a Y.
So got to put a 0 in. In matrix land, everything is super organized. Everything has to be accounted for and everything has to be lined up. So top equation has 2, -1, -1. Bottom or middle equation has 3, 0, 1. And bottom equation has 2, 5, 0. That's my coefficients. And then I have B, which is my constants, which 176. So now I'm going to put these two into my calculator. So I go back to second matrix, click across to edit, still a 3 by 3. Remember, whenever you finished putting in your any matrix at all, you hit second quit and then start over. And remember, we have to click to get B. We got to click across to edit and then down to B. It's still 3 by 1. And after you get that one in, you quit again, second quit. Now, what you are going to multiply, the way we set it up here, if you set it up like this, you are going to multiply A inverse times B. And it's going to give you an answer. So second matrix, enter, that's A. Inverse, press your little -1 button, your little inverse button, times second matrix, down to B, enter. Oh my goodness. I can't tell where you guys are at. Are you keeping up here? Okay, did you get a big long mess of decimals? Okay, so here's what I want you to do. When that happens, I want you to press your math button, just your straight math button right here. Can you see where I'm pointing? And the first option is frac. So we're going to change those into fractions. So press enter, enter, and it will pull up those numbers as fractions. So your answer is going to be 46/27, 14/27, and 17/9. We don't, if the decimals are round ones, like we had a minute ago, like 2.25, that's fine. But if your decimals are things that are big, long, hideous things, use your math frac. So your math button's right here. The first option is frac. Hit it a couple times and it'll change your things into fractions. This is the answer to the problem. Okay? All right. Well, that was a lot of fun. All right. So, gosh, yes, I see you tomorrow, don't I? So we'll have more fun tomorrow. Have a wonderful day. Thanks for coming in.
Thank you, Mrs. Ford.
You're welcome. Bye-bye.
Miss, what can I ask you a question?
Yep.